All right, everyone, this is Colty Math on the mic, getting you hyped for this video, finding the area of regular polygons. That's what's up. Okay, let's get started. Let's get focused here. All right, there are a couple of vocabulary words I have to go over and some introduction I have to do before I get into the nitty-gritty of how you would find the area of a regular polygon. So first thing I'm going to go ahead and start with is I'm going to tell you the fact that any regular polygon can fit perfectly inside of a circle. So let's say this is a perfect regular triangle, which it doesn't look like it is. I can actually put a circle around it that's going to have all the corners of the triangle on that circle. Now, I'm going to be doing things where I'm going to be putting a point on the middle of my shape. I'm going to be drawing lines that go from that center to a corner, and I'm going to be calling that the radius, because really, if I put a circle around my shape, it is like the radius of your circle. All right, now, let's get into the nitty-gritty of what this word regular means. Now, the word regular means that all sides and angles of your polygon are congruent. So you can have any shape be regular. I just drew a triangle, but you may have a square, which is a regular quadrilateral because it has all four sides congruent, and then all of the angles are, that changed, and then all of the angles are also congruent. All right, so that would be considered a regular shape. This could be a regular pentagon, regular hexagon, whatever it is, it doesn't matter. It means all the sides and angles are congruent. Now, unless your shape is regular, you cannot do this area formula. So it's only if your shape is regular. Now, the next vocabulary word that we have to go over that's new for this particular year is apothem. Apothem, very important. It's a length that goes from the center of your polygon, and then it's perpendicular to the midpoint of a side. So in our quadrilateral that I drew up here, let's say you have this being the center, right? Let's say it's the center of your shape, and an apothem would go perpendicular to one side, and it would cut it at the midpoint. So imagine where it did cross, that was the midpoint of your side, it would cut it in half. Okay? The last thing that we need to know is a central angle. A central angle is an angle that's formed by two radii, which is the plural for the word radius, and it goes from the center of the polygon, and it's going to be a formula for that central angle that's 360 divided by n. In your picture up at the top where I drew the triangle inside of that circle, if I drew in a second radius, because right now I only have one, so if I drew in my second radius here, I would be forming something called a central angle by those two radii. And the way I'd find the measure of that central angle is I would do 360 divided by the number of sides, which is 3. 360 divided by 3 is 120 degrees. So this central angle is going to be 120 degrees. And when we get into the circle unit, we're going to come right back to central angles. All right, so let's take a look at our formula finally. Okay, so here's our formula. Area of a regular polygon is A equals 1/2 times the apothem times the perimeter. Let's take a look at these two examples we have below just to practice our vocabulary before we can get into all of the formulas and then how you find each of the pieces. Now, for our regular hexagon, the first blank on the right, the top one, is showing you the side. So really, that's just the side of your hexagon. And if it's regular, all the sides have the same length. So if they put a box next to any of these sides, it would still be the same measurement. Now, this line down the middle, that's the new thing that we learned about. This is the apothem. Very, very important for today. It's the apothem. A-P-O-T-H-E-M. Apothem. All right, so it's perpendicular to your side, and where it crosses, that's going to be your midpoint. So it's going to cut that side in half. Now, the next thing that they are asking us to give a name for is this thing right here, that piece. That's going from the center to a vertex of your hexagon. That's going to be called the radius, because you want to imagine that there is this invisible circle that's going around your entire shape, and that would act like a radius of that circle. So we're going to go ahead and put in radius. And then the last thing that it's pointing to is a little dot in the middle. That's our center. I would go ahead and pause and try out the regular quadrilateral. Make sure you can identify the side, the apothem, the radius, and the center. Hopefully you did pause and you tried it out, and now I'm going to give you the answers. So the piece at the top, that's your side. The point in the middle is obviously your center. The line that goes from the center down and perpendicular to the bottom side, that's known as your apothem. And don't forget that that apothem is going to be cutting at the midpoint of that bottom side. So it is going to be congruent for both sides of that midpoint. And then the last thing, that is pointing to your radius. Anytime it's going to a corner or a vertex of your shape, that is a radius. Okay, so let's go ahead and take a look at your steps for solving these area problems. Your steps are: draw the radii and find the central angle. Step 2, draw the apothem. Step 3, bisect the side and central angle. Step 4, break out the right triangle. Okay, there's going to be a right triangle formed. And solve for the apothem and 1/2 the side using trigonometry. Step 5, find the perimeter using the side length. And step 6, plug into your formula. All right, so we wrote our formula: A equals 1/2 apothem times perimeter. And it's a little graphic organizer because it's reminding us we have to solve for A, the apothem, and P, the perimeter. So let's go through these steps. Let's see how it would work. Okay, so this shape, it has 5 sides. So I'm going to write down, I'm going to slide over a little bit here, and I'm going to write down that the number of sides, n, equals 5. All right, now with n equaling 5, I now know it's a pentagon. I can go through my steps. My goal is to find the area. The only piece of information I'm going to give you, because you have to start with some value, so the only value I'm going to give you is I'm going to tell you what the length of the radius is. And let's say it's 12. I'm making it up. Let's say it's 12, maybe centimeters. Okay? All right, so let's go ahead. Step 1, draw the radii and find the central angle. All right, I have my center. Let me draw in my first radii. I'm choosing to draw it to the bottom left. It's my choice. I'm going to draw a second radii. That's there. Okay, and now I had to make sure that I connected 2 consecutive vertices to your center. You want to draw your 2 radii so they're to the 2 vertices that are next to each other. Anywhere in your shape, just as long as they're the 2 vertices that are next to each other. Now I also need to find the central angle. Now that's the angle right up here. Remember, to find the central angle, you're going to do 360 divided by the number of sides, in this case 5. All right, in our calculator, we do 360 divided by 5, 72. So 72 degrees is the measure of my central angle. I'm not going to put that in just yet, and you'll see why. Next, step 2. Draw the apothem, which is perpendicular to the midpoint of a side. We're going to use the side at the bottom because that's the side that's stuck between your 2 radii. Okay? So we're going to go ahead and draw the apothem from the center, perpendicular down to your side, and I'm going to show that it's the midpoint. So I'm going to show it was cut in half. Now, step 3 said bisect the side, which we kind of already did, but let me give it each an X, just to make sure I show myself that I cut that side in half. And also, not only are you bisecting the side, but your apothem is also going to bisect the central angle. So it's going to bisect the angle that's 72 degrees. So we need to do 72 divided by 2. So in our calculator, we're going to do divided by 2, take half of it. which is 36. So we have 36 degrees for the angle on the right, and then 36 for the left, but the whole angle is still 72. Now, it says for step 4, break out the right triangle. So we have two little right triangles formed, doesn't matter which one I break out, and then solve for the apothem and 1/2 of the side using trigonometry. So I need to solve for the apothem. I'm going to color code that pink. So that's this length right here. And I need to solve for 1/2 of a side. Now that 1/2 of a side is that little piece of your right triangle. All right, so let's go ahead and break out that right triangle. Okay, here's our shape. Let's go ahead and label in what we know. So we know this angle is 36 degrees. We also know the radius is 12. Okay, so I haven't put that in yet. Let me go ahead and put that in. My radius, those two blue lines, they're 12 centimeters each. Okay, now I have a value. Good. All right, so that 12 centimeters is actually acting as a hypotenuse to my little right triangle. So I'm going to put it in here, 12 centimeters. And then I have x, which is missing. I have my right angle here, and then my apothem is missing as well. And I'm going to call that A. So this apothem is A. All right, so I need to solve for my x and my A. I'm going to use trig. I'm going to start with the x. So 36 degrees is my reference angle. Here's my opposite side. My A is my adjacent side, and the 12 is my hypotenuse. So if I'm solving for the x, that's my opposite, I need to use the hypotenuse, so I'm using so. I'm going to do sine of 36 equals the opposite side of x over the hypotenuse of 12. Multiply both sides by 12, and now my calculator, I'm going to do 36 sine times 12. And I get that 7.0534. Okay, 7.0534. I'm going to go out 4 decimal places. That's your x. All right, so I have that. Now, if this is 7.0534, I'm going to double it so that I can actually find the whole side length. So I'm going to do times 2. So my one whole side length is now 14.1068. And then I can also, if I preview step 5, I can find the perimeter because all of these sides should be the same. They should all be 14.1068. So what I'm going to do, I'm going to solve for the perimeter really quickly because that number is in my calculator. So I'm going to do 14.1068 times 5 because there are 5 sides. And that's going to give me the perimeter. So my calculator, times 5 equals 70.5342. That's my perimeter. Okay. Oh, it's actually 0.423. Let me change that. 0.4, 0.4. Oh, I got it right. 75342. Okay, I'm good. All right. Now the next thing that I need to do, I need to solve for the apothem. So let me just give myself a little bit more room. And this is reminding you of your SOHCAHTOA stuff. And I'm going to go ahead and solve for the apothem. So the apothem is my adjacent, and I have the hypotenuse, so I'm going to use cos. Cosine of 36 equals the adjacent A over your hypotenuse of 12. Cross multiply, and we get in our calculator 12, oh, I'm going to do the 36 cosine first, times 12, so it's going to be 9.7082 is your apothem. That's the length of your apothem. Awesome. Bring it right up here. Write it down. 9.7082. And now we're going to multiply the apothem times the perimeter and then divide by 2. So it's in my calculator already. Going to multiply by 70.5342 equals, then I have to divide by 2 or multiply by 1/2. That's my final answer. It's going to be 342.4 if I round to the nearest tenth centimeters.